Hello everyone, this is Nepalidi sir from ANR Academy. Today we are going to discuss objective problems based on the topic logarithms. Before going to discuss different types of questions, let us discuss first the definition. You know that logarithmic function which is defined by f of x equal to log x to the base a and is defined for all x values more than 0, and here the base a, it has two conditions, that is base value more than 0 but not equal to 1. You know the definition of logarithmic function. With the help of these conditions, let us discuss the problems which are asked previously in the entrance examinations. Let us discuss first question. See this question. Here you have the question, number of real solutions of log x minus 1 to the base 4 which is equal to log x minus 3 to the base 2. You need to find number of real solutions in this case. And observe here, left hand side, right hand side, both you have logarithmic function, but observe here, first one to the base 4, second one to the base 2. First I am going to equate the base. First I am going to write 4 as 2 square. Next here the second term log x minus 3 base 2 in the right part as it is. You know that logarithmic property log a power m base b power n, that can be written as m by n log a to the base b. Using this property, here this is x minus 1 whole power 1, right? It looks like log a power m base b power n. So I am going to write the formula m by n log a base b, that is, here we get 1 by 2 log x minus 1 to the base 2, and in the right hand side log x minus 3 to the base 2, and it can be rewritten as log x minus 1 to the base 2 equal to 2 times of log of x minus 3 with base 2. And also you have the formula, you have the property log a power m, that can be written as m of log a. In the right hand side it is like m into log a, you can write log of a power m model, so that it is log of x minus 1 to the base 2 written as log of x minus 3 whole square with base 2. Here left side and right side logarithmic function now with equal base, so that I am going to equate input x minus 1 here and x minus 3 whole square in the right side. On simplification, you get the value of x. See, this is x minus 1, in the right part it is x square minus 6x plus 9. Also you can simplify this, x square minus 7x and plus 10 equal to 0. Here it gives the result x minus 2 into x minus 5 equal to 0, and hence the values here you got 2, 5. But here you have to observe the definition. After getting the values of x, once again you have to cross check whether they satisfies logarithmic function or not. Why? Because logarithmic function is defined only when input is non-negative real number. Here if you write x value 2 what happens? Observe. 2 minus 1 it is, and here it is 2 minus 3. So when you put x value 2, input become plus 1 in the left hand side, minus 1 in the right hand side. Log minus 1, that is not defined. So no need to select the value of 2 as real solution here. And in case if you write the value of 5, here the input become 5 minus 1, that is 4. Clearly that is non-negative real number as input. And when you write in the right part 5 minus 3, that become 2. 2, that is non-negative real number, and hence only one solution you have, that is x equal to 5. Therefore number of real solutions for this question, only one solution, particularly that is x equal to 5. Remember. Let us move to the next question. Second question here. You have first one in this, log of 2x plus 3 to the base 3, which is less than log of 4 minus x to the base 3. Same base you have, but inequality is there, less than condition. And here one more question is there, log of 2x plus 5, but the base is 0.3 and less than log of 4 minus x to the base 0.3. See these two questions, here only the difference in base, input is same. Here you have 2x plus 5, 4 minus x. Here input you have 2x plus 5 and 4 minus x. Only the difference in base. Here you have base value more than 1, and there the value of base in between 0 to 1. Here whenever the base value more than 1, you know that logarithmic graph, that is increasing graph, when base value more than 1, you will get the graph in this way. Next, decreasing graph in case of base value between 0 to 1. You know this. This is the graph of logarithmic when base value between 0 to 1. And this is the graph of log x when base value more than 1. Let us observe these two figures. If suppose there are two inputs, suppose for example this is x1 and this is x2, and here the relation between inputs x1 is less than x2, and observe corresponding outputs f of x1 and f of x2, that is in this case due to logarithmic function this is log x1 and this is log x2. Clearly log x2 is greater compared with log x1. So here log x2 greater compared with log x1, and here there is the relation between input and output. x1 less than x2 implies log x1 also less than log x2. The same identical condition you have for input as well as output in case of increasing function. Remember, suppose that if the graph in decreasing manner, then see the relation between inputs and outputs. Clearly x1 is less compared with x2, and its output, if you observe, this is log x1, and here you have this output become log x2. But in this case, due to decreasing function, log x1 is more compared with log x2. Here log x2 is smaller compared with log x1. So in between log x1 and log x2, I can write the relation log x1 is more than log x2. So here the inequality is in different way compared to input and output. Here x1 less than x2 implies you have log x1 more than log x2. But here x1 less than x2 implies log x1 also less than log x2. For increasing function, you have identical symbol, both less than symbol. And here when the function is in decreasing manner, then you have different symbols. Between x1 x2 less than symbol, between log x1 and log x2 you have more than symbol. So D for decreasing, D for different. In such a way you can easily remember this condition. Identical and increase. For increasing function, the relation between input and output with same identical conditions we get, and in case of decreasing function you will get different notation. So now the same here I am going to apply log, this is like log x1 log x2. Here inputs both x1 and x2 are 2x plus 5, 4 minus x. Since it is of increasing function, if I write the relation between x1 and x2, that is in between 2x plus 5 and 4 minus x, the same symbol we have to use. And in this case, since base value 0.3, due to decreasing function, the relation between both the inputs 2x plus y and 4 minus x, that should be with greater than symbol, remember. Why? Because for decreasing function different symbol, for increasing function you have to follow the same symbol. Yes. Now I am going to solve these two questions. Here the relation between inputs 2x plus 5 and 4 minus x, you will get with the same notation less than. But here due to decreasing function, the condition 2x plus 5, which is more than 4 minus x, remember. Now I am going to solve this. 2x plus x, which is less than 4 minus 5, nothing but 3x, which is less than minus 1, x is less than minus 1 by 3, minus 1 by 3 here you have, and here 2x plus x more than 4 minus 5. Next, 3x is greater than minus 1, x is greater than minus 1 by 3. Here you have x value less than minus 1 by 3, but there you have x value more than minus 1 by 3. And also you have to remember the basic definition of logarithm. For what values of x it is defined, that you have to verify first. Observe here, there are two conditions. One is, first one is defined only when 2x plus 5 more than 0, and also second one here 4 minus x more than 0. It means x is more than minus 5 by 2 and this is x less than 4, remember. The same condition applicable here. I am going to write x value more than minus 5 by 2 and x value less than 4. These are the two conditions you have to apply in the solution. See, here in the first question, the values of x, first less than 4. Less than 4 means left side of 4. Next, less than minus 1 by 3. Minus 1 by 3 value approximately minus 0.3. Here suppose that it is minus 0.3. The values of x less than this. Next, x value more than minus 5 by 2. Minus 5 by 2 minus 2.5. This is minus 5 by 2 and the values are more than this, right part. So common values of these three, x less than 4, x more than minus 5 by 2 and x less than minus 1 by 3. The three common values we get here. So that Here the answer x belongs to minus 5 by 2 comma minus 1 by 3 with open brackets. Next, here in the second question, this is real line, x value less than 4. Less than 4 means left side of 4. Next, this one over. Next condition, x value more than minus 5 by 2. Minus 5 by 2, minus 2.5, more than this. So, in the right hand side. Next, x value greater than minus 1 by 3. Greater than minus 1 by 3, nothing but greater than minus 0.3. So, to the right part. Now, the common solution you will get in this portion, and here the values of x belongs to open interval minus 1 by 3 comma 4. These are the solutions for these two questions, and one is with base more than 1 and the other with base in between 0 to 1. So, the students, by observing the base, you have to write the same inequality for base more than 1, and you have to write different inequality when base value between 0 to 1. That you have to observe, and also you have to apply the basic definition of logarithm. Logarithmic function which is clearly defined when the input is non-negative, remember. Those conditions also you have to apply in the solution. Let us move to the next question. See this, log of x square minus 5x plus 87 greater than 0, and there are different bases. First log with base 4, next log with base 2, and then with log base 2, and last one with base 3 you have. See, both the sides, if you apply base 4, then what happens, observe. Both the sides, base 4 I am going to apply. 4 power log with base 4, nothing but these two are inverse to each other, they gets cancelled, remaining part you will get, and in the right hand side you will get 4 power 0, that is 1. There is no change in the inequality, remember, due to the base value clearly more than 1. In case base value between 0 to 1, then in that case you have to change the inequality. But here all the logarithms having base quantity more than 1, so that no need to change the inequality in this case. Just what I applied, both the sides, if you apply base 4, right hand side 4 power 0 1, and in the left hand side 4 power log with base 4. These two are inverse to each other, they gets cancelled. Remaining terms you will get, they are log with base 2, log with base 2, log with base 3, inside x square minus 5x plus 87. Now, in the next step, I am going to apply base 2 on both the sides. Here base 2 and here base 2 I am going to apply. Then what happens when you apply the base, observe, here 2 power log again with same base 2, and hence these two are inverse to each other, they gets cancelled, only you will get these two logarithm terms, and in the right part 2 power 1 is nothing but 2, and here these two exponential and logarithm gets cancelled, we get log of x square minus 5x plus 87, and here the bases are here 3 and here it is 2. In the next step, both the sides you have to apply the base 2. Again here you have base 2. Both the sides if you apply base 2, what happens, observe, exponential logarithm gets cancelled, only you will get this portion, that is log of x square minus 5x plus 87 with base 3, and this one 2 power 2, nothing but 4. One more step, apply base 3 on both the sides now. then automatically exponential logarithm will gets cancelled. We get only the second degree part, x square minus 5x plus 87, which is more than 3 power 4 nothing but 81, and x square minus 5x plus 87 minus 81, that becomes 6 more than 0, and hence the factors of this x minus 2 into x minus 3 more than 0. X minus 2 into x minus 3, it indicates a parabola passing through x equal to 2, x equal to 3. This is the parabola. Second degree equation indicates a parabola passing through 2 comma 3 due to factors x minus 2 and x minus 3, and parabola more than 0. More than 0 nothing but the graph should be entirely above x axis. The portion, parabolic portion more than 0 part, this one, this shaded portion in which parabola is greater than 0, and the values of x satisfying the parabola more than 0 are more than 3, less than 2, and hence here I can write the values of x are minus infinite to 2 union 3 to infinite, and you cross check the values of x. If you write more than 3 or less than 2, whatever in this, it is well defined. Why? Because x square minus 5x plus 87, which is greater than 0, while writing the values of x more than 3 or less than 2, that you have to check. So this is the solution for this question. Let us move to the another one. See the question. Left hand side you have log y, that is equal to, in the right part you have x into log 2 by 5, and given the condition x belongs to natural number union a singleton set 0, and the question is find the sum of values of y. Yes, left hand side there is one variable y, and in the right hand side another variable you have x, and given that x values are natural numbers including 0, natural numbers also one more element 0 included, so that x values are whole numbers in this case. Natural numbers union 0, nothing but x belongs to whole numbers given, but here the requirement is sum of values of y. Let us see the solution. Here you have log y equal to x into log 2 by 5. Here left hand side log y as it is I am writing, and in the right hand side, since m into log a, that can be written as log a power m, so here it can be written as log 2 by 5 whole power x. Both the sides, if you neglect logarithm, then you will get the value of y equal to 2 by 5 whole to the power of x. Observe the question clearly. When log y equal to x times log 2 by 5, and clearly x belongs to whole number, then what is sum of values of y? There are different values of y exist depending upon the value whole number, right? So if x 0, you will get one solution for y. If you write x value 1 and then 2, 3, 4, you will get different values of y, and those values of y you have to add up, then only you will get sum of values of y. So here, suppose x equal to 0 implies the value of y become 2 by 5 whole power 0, nothing but 1. Next number, x equal to 1, if you write y equal to 2 by 5 whole power 1, nothing but 2 by 5, and then I am going to write the value of x equal to 2. What we get? 2 by 5 whole square. Yes, as it is 2 by 5 whole square, and so on. There are so many values of x, and for which you will get so many values of y, nothing but infinite values of input for which infinite values of output you will get, and sum of all outputs, that is y equal to, clearly here sum of y, right? Here you need to find sum of all y's, so that I am writing sum of values of y equal to, first element you have 1, and then you have 2 by 5, and after that you have 2 by 5 whole square, and so on. If you continue input whole numbers, you will get continuously the values of y infinitely. Clearly here the sequence of terms which are in geometric progression, the sequence of terms in GP, and also there are infinitely many terms, so you have to apply sum of infinite terms in GP formula, a divided by 1 minus r. Clearly mod r less than 1 in this case, due to the value of r here 2 by 5. So you can apply this result, a by 1 minus r. A is nothing but first element and common ratio, that is 2 by 5. On simplification we get, this is 1 by 3 by 5. Finally we get 5 by 3. This is sum of values of y in this question. In the next session we will discuss different types of questions. Thank you so much.